Hello class, and welcome to Chapter 3 of our Cornerstones of Cost Management text. This is quite a long chapter, so we're going to get right into it. This chapter deals with cost behaviors. Um, After we're done with this chapter, we should be able to define and describe fixed, variable, and mixed costs. We should be able to explain the use of resources and activities and the relationship to cost behavior. We should be able to explain how several methods of cost estimation can be used. We should be able to separate mixed costs into their fixed and variable components using the high-low method and the scatterplot method and the method of least squares. We should be able to evaluate the reliability of the cost formula, explain how multiple regression can be used to assess cost behavior, define the learning curve and discuss its impact on cost behavior, and discuss the use of managerial judgment in determining cost behavior. Basics of cost behavior. The term used to describe whether a cost changes when the level of output changes. Fixed costs do not change as output changes, whereas variable costs increase in total with an increase in output and decrease in total with a decrease in output. Remember, variable costs are directly tied to the per unit that we manufacture or create. Cost objects are an item for which managers want cost information. For manufacturing or merchandising firms, it is usually the tangible product. And for service firms, it's usually the service provided. Measures of output. Activity drivers explain changes in activity costs by measuring changes in activity output. The two general categories of activity drivers are unit level drivers and non-unit level drivers. So fixed costs are costs that are in total are constant within the relevant range as the level of activity drivers varies. So we might be able to create 20 to 60,000 units and have the same fixed cost. So as an example, JCM Auto Systems Incorporated produces speakers for home audio systems. One department produces voice coils. There are two production lines that can each make up to 100,000 voice coils per year. The production line manager is paid $60,000 per year. For the production up to 100,000 units, only one manager is needed. Above that, up to 200,000 units, two managers are needed. So, up to 100,000 units, our fixed supervision cost is $60,000. But once we jump in over the 100,000 unit range, we need another manager, so our supervision cost will go up to $120,000, and we'll see that per unit cost jumps up, but then slowly moves back down as we start getting up to the 200,000 unit range. So we can see that visualized here. The $60,000 range dollar range goes up to the 100,000 units, whereas the $120,000 supervision cost range goes from 100,000 to 200,000 units. Technically, you could go from 0 to 100,000 units, but that dotted line shows what would be unnecessary there. So variable costs are costs that in total vary in direction proportion to changes in activity in an activity driver. The total cost of direct materials for each level of production varies, but the unit cost stays the same. So the total direct materials cost of the voice coils might be $120,000 for 40,000 coils, but again, that's $3 per unit. And as we see this step up, that unit direct materials cost per voice coil will remain at $3. And that might be true for the entire production line, no matter how we can produce. Now, if we can leverage economies of scale, we might be able to purchase those direct materials at a lesser per unit price, which might bring our unit direct materials cost down per unit. Let's say we might have to make 500,000 voice coils in order to reach that direct material quantity to get that sort of a discount. So this relationship can be shown on a graph with a straight line. It's basically y mx plus b, and m is our and the b is 3, right? That's our slope, so it's $3 per unit. Mixed costs are the costs that has both a fixed and a variable component. So we might have y represents a mixed cost, and that equals a fixed plus total variable cost, or fixed plus variable times x, which is the number of units produced. So JCM sales costs are mixed. There are 10 sales representatives who each earn $30,000 plus receive a commission of $5 per speaker. So we see this is the formula how we would lay that out. This function can be represented by the following equation right here. So we have our mixed cost y, our fixed portion of that mixed cost, which is $30,000 per sales representative, and we have 10 sales representatives, so that's $300,000. And then we have plus $5 times the number of speakers sold, which is x. So we can see that here in this graph. If we sell 40,000 speakers, we have a total cost of $500,000. 300,000 of that is fixed, and 200,000 is variable. So our total mixed cost is 500,000, and we get a total selling cost per unit of $12.50. And as we move up the units, we see that total selling cost per unit go down. Our variable costs of selling goes up, but our fixed cost remains the same. So we can see that represented here, where the 300,000, that's where our line starts right here on the x-axis at 300,000. So even if we sell no units, we might need to fire these people at the end of the year, but we had $300,000 worth of salaries to start with. Resources. Economic elements that enable one to perform activities. When a firm acquires the resources needed to perform an activity, it obtains activity capacity. So resources might be plant equipment or personnel. And practical capacity is the activity level where the activity is performed efficiently. So flexible resources are supplied as needed and used. And a quantity of resources supplied equals the quantity demanded, and this in an ideal scenario has no unused capacity. We use these resources as needed. Committed resources are supplied in advance of usage, and a given quantity is obtained whether or not that full amount is used. And this has possible unused capacity. So if we're making something, let's say we're cutting something out of sheets of steel, we can only order those plates of steel in full plates. So if we don't cut the total number of units that equals an even number of full plates, or at least, when we're talking about full plates, let's say there's 100 units that can be cut out of a plate, but we only make 175. We have 25% of one plate that's going to go unused, and that would be a committed resource because we can't buy 75% of a plate. Step cost behavior is a step cost is a function that displays a constant level of cost for a range of output and then jumps to a higher level of cost at some point. So that would go in the sheets of steel example that we just talked about. So step variable costs follow a step cost behavior with narrow steps, and step fixed costs follow a step cost function and exceed the relevant range, and the costs increase one step. So we can see this here where we're going to have $100 of cost for the first 20 units, and after that we're going to have another $200 of cost. So even if we only produce 21 units, we're going to have $200 of cost all the way up to 40 units, and so on. So for fixed costs, it's the same principle, it's just bigger numbers generally. So activity output in this graph is the number of engineering change orders. So we see up to 2,500 ECOs, we're going to have $50,000 of cost. And then from there, we're going to jump up to $100,000 of cost. And we'll see that keep stepping as we go. Activities and mixed cost behavior. Many activities have characteristics of both flexible and committed resources. For example, a power department acquires long-term capacity for supplying power by investing in building and equipment, but it also acquires fuel to produce power on an as-needed basis. Need for cost separation. Sometimes it's easy to spot the variable and fixed portion of a cost. Other times it's not. Thus, there's a need for a method to separate costs into their fixed and variable components. So there's different methods of determining a cost behavior. The industrial engineering method is a forward-looking method of determining through physical observation and analysis just what activities and what amounts are needed to complete a process. And the account analysis method is used to estimate costs by classifying accounts in the general ledger as fixed, variable, or mixed. And that's probably what we're most used to seeing. So again, a mixed cost is y, and it equals f, which is a fixed cost, plus v, a variable cost, times x, which is the number of units produced. Then there's the high-low method. The high-low method takes 2 points, the high and the low by volume of activity, and determines the slope and intercept. The slope is a variable rate, and intercept is a fixed cost. So the advantage of this is it's objective. Generally, we have an idea of what our high and low outputs will be. It's very simple to calculate, but there's some disadvantages. The disadvantages are that the high and low points are oftentimes outliers. They don't represent normal activity for a business. And other pairs of points may clearly be more representative. So then there's also the scatter plot method, which uses a scatter graph to visually assess the relationship between costs and output. Intercept is again a fixed cost, and the slope is a variable rate. The advantages of this method is that it allows for visual inspection of the data and identifies non-linearity, outliers, and shifts in the cost relationship. But the disadvantages are that it's subjective. We have to make a lot of estimates, and there's going to be some opinion input into those estimates. So if we looked at the graph of data points for our costs at different activity levels, we would see this here, and this would be a scatter graph. But if we drew a line through our outliers, our high and low points, which happen to be 1 and 5 on this graph, we would see that it gives us a reasonable slope. The line is a reasonable representation of what we might do, but we have a few kind of large outliers, namely 4 and 9 and maybe 2. Now, if we actually just drew a midpoint slope of a scatter graph, we would see something like this, where we might not have as many outliers that are that far outside of our line, but I think we don't necessarily have as good of a representation of an average of what we might see. But that would vary. Again, that would vary depending on the scatter graph itself. Scatter graph for this is another example of a scatter graph, and remember, it's a nonlinear relationship. So scatter graph can be all over the place, and as we see here, our cost is going down, or our cost per unit seems to be going down with our activity output. But this is an upward shifting cost relationship, so our cost per unit seems to have a large jump when we get over a specific level of activity output. And then this is just an example of a presence of outliers. So we see this dot here and this dot here. The rest of these really could probably be estimated pretty well because they seem to follow a linear graph. But for whatever reason, at these activity levels, we have cost drops and spikes that we wouldn't necessarily predict with a line, a linear graph. Deviations of a data form line are represented here, so they're showing the different deviations for each point on the line, and you would be able to measure what those deviations were if you actually had the specific data. With that said, we're going to look into using Excel here in a minute to interpret some of this data and use it, but this video is approaching on 15 minutes, and I like to cut them off there so you can watch them in manageable chunks. So again, I will see you for the next part of Chapter 3. If you have any questions, please let me know. Thanks.